Today we are talking about a cyclic quadrilateral. Okay, if all the four vertices of a quadrilateral lie on a circle, then we call it a cyclic quadrilateral. And let us get a bit of clarity here. You can draw a circle. It's a unique circle passing through any three vertices of a triangle. Okay, but the question is about the fourth point, because the fourth point can be inside the circle or outside the circle or on the circle. So here we are telling very categorically all the 4 points. So you can draw a circumcircle of a triangle, but we are bothered about the fourth vertex. So in a quadrilateral, if all the 4 vertices of the quadrilateral lie on a circle, then that quadrilateral is called a cyclic quadrilateral. A cyclic quadrilateral you are seeing here, you can change the shape of that. Okay, these are all cyclic quadrilaterals. So this is also a cyclic quadrilateral. I can change the vertices, but all the time they lie on the circle. So that's what we mean by a cyclic quadrilateral. And let us see a few properties of this cyclic quadrilateral. One of the most important property here is that opposite angles of a cyclic quadrilateral are supplementary. So if you add angle A and angle C, you get 180 degrees. And also angle B and angle D also will give you the same sum. Angle B plus angle D, opposite angles if you add, this is angle D and this is angle B, and sum of those two is 180 degrees. Then you say those two angles are supplementary angles. Let us understand how we can prove it rather. So I have all the 4 triangles shown here. They're all isosceles triangles because this is radius and this is also radius. And as these two sides are equal, this becomes an isosceles triangle. In fact, all the 4 triangles here are isosceles triangle. In an isosceles triangle, you can understand that the base angles are equal. That's why we have represented here, this is red and this also is in red color. You see this isosceles triangle, this here you find blue color and here also you find blue color because those two angles are equal. And similarly here you can see brown and brown, and here you see green and green. So there are 4 isosceles triangles. In each case you find that the base angles are equal. Now if you add all the 4 angles of the quadrilateral, that must be 360 degrees. Let us see what all we have. We have 2 reds, 2 greens and 2 browns and 2 blues. If you add all of them, you must get 360 degrees. Then let me know the half of that. So 1 red, 1 green and 1 blue and 1 brown, if you add them, it should be essentially 180 degrees. So if you want to mark them with alphabet, you can say A and A are equal, base angles. B and B are equal, they are in green color, base angles. Brown and brown, they are equal, you can say C and C, and blue angle here D and D. If you want to add all the 4 angles of the quadrilateral, you will have A plus A, 2A, B plus B, 2B, C plus C, 2C and D plus D, 2D. So sum of all the 4 angles of the quadrilateral, you will have 2A plus 2B plus 2C plus 2D. But you look at opposite angles of the quadrilateral, you will have 1A, 1B, 1C, 1D. So the answer will be 180 degrees. And so opposite angles of a cyclic quadrilateral, they are supplementary because sum of those 2 opposite angles will yield only 180 degrees. Okay, all the time so angle B plus angle D is equal to 180 degrees and angle A plus angle C also is equal to 180 degrees. So sum of the opposite angles you find 180 degrees. Therefore we say opposite angles of a cyclic quadrilateral are supplementary.